Today we're going to look at equations of lines. There are three forms of equations of lines that we're going to look at. The first is slope-intercept form. You use that primarily when you want to graph a line. The next is point-slope form, and you use this primarily when you want to find the equation of a line and you know a point and a slope, or you know 2 points. And the third form is standard form. We write a line in standard form so that we're all the same. It's easier to compare equations. Okay, so let's just take a quick review of slope-intercept form. You know that m is the slope, b is the y-intercept, and then the y and the x are the variables that make it into a line. So for example, if I have y equals 3x minus 4, 3 is the slope, and the y-intercept is 0, negative 4. So what? Well, knowing the slope and the y-intercept makes it easy to graph a line. Let's go back to y equals 3x minus 4. We know the slope is 3. We know the y-intercept is 0, negative 4. So if I want to graph, I start by placing a point on my y-intercept, and the slope of 3 means 3 over 1, so that means I have a difference in the y-coordinates of 3, difference of the x-coordinates is 1, so that means I can go up 3 and over 1 to find another point, and I can continue doing that till I have enough points so I can draw a nice line. Very important thing to know, and a very handy thing to be able to use to graph lines. So now we want to really focus on writing equations of lines, and you write equations of lines by using point-slope form. Okay, so yeah, you might, if you have the slope and the y-intercept, use slope-intercept form, but usually you're going to be writing the equation of the line using point-slope form. So point-slope form again is right here, where the slope is represented by m and the point is represented by x1 and y1. The y and the x again are your variables so that you have an actual line. So let's do an example. Suppose I want to find the equation of a line with slope of 3 containing the point negative 2, 4. Then I know that my slope is 3, and I know that my x-coordinate is negative 2, that's my x1, and I know my y-coordinate is 4. So I use point-slope form, and I substitute those values in for the slope and for the point, x1 and y1. And now I've got the equation of the line with slope 3 and going through the point negative 2, 4. Now, make sure again you leave x and y alone. They're not to be substituted. They're part of the equation. So do you want to simplify it? Probably you do. Not often do we say leave it in point-slope form. So first step, of course, would be to distribute the 3. You might choose to put it in slope-intercept form by adding a 4 to both sides. You might want to put it into standard form. You would do that by subtracting a y and subtracting a 10. Remember, in standard form, you want that leading coefficient on the x, the 3, to be positive. It doesn't matter what the coefficient on the y is, whether it's positive or negative. It doesn't matter if the constant is negative, but that leading coefficient you want to be positive. And remember, no fractions. So some important things to remember. If you need to find the equation of the line, I should probably say almost always start with point-slope form. Even if we ask you to find the equation of a line in a different form, for example, we say find the equation of a line in standard form. That doesn't mean you start with standard form. You always start with point-slope form and then change to the other form. Remember, don't fuss with the x and the y, only the x1, y1. That's your point. When changing from point-slope form to a different form, be sure to distribute the slope correctly. Remember, it has to be distributed over both terms. And what if you don't have a slope? Well, if you're given 2 points, you can always find the slope. Then you can choose either of the 2 points for your point, x1, y1. The only other tricky thing is horizontal and vertical lines. So remember, a horizontal line All of the y-coordinates are the same. So if you look at the graph, you can see all of the y-coordinates in this example are 3. The equation in general is y equals a constant. Here y would equal 3. And you know the slope is 0. A vertical line, all the x-coordinates are the same. So look here, all the x-coordinates are -2. The equation in general is x equals your constant. In this case, it would be x equals -2, and your slope is undefined. The only other thing I want to talk about are parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. So what's that mean? Well, let's look at our example equation, y equals 3x minus 4. The slope of this line is 3. The slope of the line parallel to it is 3. And the slope of the line perpendicular to it, remember, negative reciprocals, is -1/3. You take the reciprocal and you take the opposite of that slope. Here's an example. Suppose I want to write the equation of the line parallel to y equals 3x minus 4 that contains the point -2, 4. I'm going to use point-slope form. I know my slope is 3 because I want something that's parallel. And I am containing the point -2, 4. So that's my x1, y1. So I write down point-slope form. I substitute in, and then you can simplify at least to x plus 2. And then depending on what form you're asked to write it in, you would continue to transform that equation into that form. Here's another example. Write the equation of the line perpendicular to y equals 3x minus 4, containing that same point, -2, 4. Again, the slope is this time -1/3 because it's perpendicular, so the slope is a negative reciprocal of the original slope. Point is -2, 4. So again, using point-slope form, I substitute in my point and my slope, and then from there I would simplify that or transform that equation to whichever form I was asked to write. Okay, that's it for right now. You need to practice these, but this is the general information for writing equations of lines.